So welcome to this week. We're going to start talking about inferential statistics this week. And what inferential statistics is basically we've got sample data. Now I want to make generalizations about some population. And one of the ways we're going to do this is by using probability distributions. Now a probability distribution, it's just like a frequency distribution. So we rolled dice, we flipped coins, and what we can do is record how many of each we got. So how many 2s did we get? 3s, 4s, 5, 6, 7, 8, 9, 10, 11, 12. How many of those did we get when we rolled the dice? And each of us did that for our 40 rolls of the dice. And that would be our frequency distribution. Possible outcomes, and then how many times did they happen. You flip the coin, and you counted how many tails you got, how many heads you got in 40 flips. That would be the observed probability or the empirical probability. What a probability distribution is simply, in a way you can think of it as the theoretical frequency distribution. So we've got heads, we've got tails, each has a probability of 1/2. If we roll the dice, we can calculate the probability of getting a 2, a 3, a 4, a 5, 6, 7, on up through 12. And when we calculate those probabilities, that will give us the theoretical probability of something happening. And what we'll do, we'll take frequency distributions or empirical probabilities and compare them to probability distributions or theoretical probabilities. So for example, if I roll a dice, or one die, 100 times, let's say, in theory, I'll get about 1/6 1s, 1/6 of them will be 2s, 1/6 will be 3s, 4s, 5s, and 6s. The theoretical probability of each number is 1 out of 6. Or if I come up with a probability distribution, I'm simply saying the value of 1 has a probability of 1/6, the value of 2 has a probability of 1/6, the probability of 3 is 1/6, etc. That's my probability distribution. That's what I expect to happen. And then what I do is I get my empirical probability or my frequency distribution, and I can see whether what I actually roll in those 100 rolls looks about like what I would expect in theory. So I'm going to roll the dice 100 times. I should get about 1/6 1s, about 1/6 of them will be 2s, 1/6 will be 3s, etc. Is it going to be exact? No, it's not going to be exact. Just because it's a sample, it's not going to be exactly what you expect. By the law of large numbers, though, we know that it'll be about what we expect. And what we can do, say we have a die, say now this is a perfectly fine die, and I'm going to roll it. If we get, 2/3 of them are 1s or 3/4 of them are 5, maybe we'll say, you know what, the empirical probability, my frequency distribution doesn't look like my probability distribution or what I'd expect, so maybe it's not a fair die, maybe it's loaded somehow. And that's how we'll use probability distributions as a way to check and see if the things we come up with in real life or our empirical probabilities, whether they match our theoretical probabilities.